Probability or chance is how likely something is to happen. So how do we calculate probability? The formula is quite simple and intuitive. So in order to calculate a probability of something, P of something happen, okay, is equal to the number of ways it can happen, okay, divided by the total outcome. Right. So for example, if I toss a coin, right? So what is the chance of me will get in ahead when I toss a coin, a fair coin? So, well, what is the total outcome? Either I can have a tail or a head. So there are two total outcomes, right? And how many sides of the coin that have a head? One, right? So the probability of getting ahead when toss a coin will be 1/2. Okay. Now, suppose that we are interested in the relationship between two events. We'll call it event A and event B. So for the first situation, independent events, A and B are independent, then the probability event A occurring has no impact on the probability of event B occurring, and vice versa. Okay. So for example, if I toss a coin and I get a head in the first toss, what is the probability of me getting another head on the second toss? Well, it's simply still 1/2, right? Because what it did happen has nothing to do with the current situation. Okay? So for the Venn diagram, it looks like this. So I have two circles, right? So this is my event A and event B, right? And it turns out that in probability notation, when I want to figure out what is the probability of event A and event B happen, it is equal to the products of the two probabilities. So P of A and B is equal to the probability of A times the probability of B. Right? So usually the probability that involve two events where you have an and, that's going to be less likely, more restrictive, because you have more conditions, right? Because think of it in terms of mathematics. If you take two numbers that are less than one, well, between 0 and 1, and you multiply them together, like a half and a half, you get a quarter, right? So it gets smaller. The probability of A and B happen together at the same time is smaller. So the next event will be mutually exclusive event. Event A and B are said to be mutually exclusive, or sometimes people call it disjoint. If A occurs, B cannot occur. And if B occurs, A cannot occur. So for example, it's either raining outside or it's not raining outside. Like it cannot be both. Okay? So they do not contain any of the same outcome. Their intersection is empty. In probability notation, this can be, actually, let me show you the Venn diagram first. So if I have event A and event B, there is no intersection between the two. Okay? So in terms of probability notation, P of A or B for the mutually exclusive event is just equal to the sum of the probability of A plus probability of B. Right. Complementary events. event A and B are said to be complementary events if there are two things occur. Event A and event B are mutually exclusive. So that means P of A and B is equal to 0, right? Maybe I should add it here. Maybe I should add it here, P of A and B is equal to 0 when the event A and B are disjoint, right? Because there's no intersection there. So complementary event, A and B are mutually exclusive, meaning probability A and B occurring together is 0, right? And there are no other possibility other than event A and event B, meaning that there are only two possible outcomes, right? So on the Venn diagram, there are only two possible outcomes, A and B, and it make up the whole space right there. Okay. So for example, when you go to an interview for a job, the outcome is either you get a job or you don't get a job, right? There's no other possibility. Okay, so let me write here, P of A or B is equal to 1, right? Or P of A plus P of B is equal to 1 because they are mutually exclusive, right? Their P of A or B is equal to P of A plus P of B. And for the complementary events, sometimes they denote P of B is a P of A complement because there are only two events, right? Either you are event A or you're not event A. So I can replace P of B as, so I can replace P of B as P of A complement. So P of A plus P of B complement is equal to 1. This implies that P of A complement, let me do it in yellow, P of A complement is equal to 1 minus P of A. And so this B right here is the same thing as A complement. Last but not least, let's take a look at the inclusive events. So event A and B are said to be inclusive if A and B can both occur simultaneously. Right? So for example, what is the probability of me rolling a 6 or a multiple of 2? Right? So in first glance, we can naively say that, hey, I can add up the probability of rolling a 6 and the probability of rolling a multiple of 2, and that's it. But remember, these two events are not mutually exclusive, right? So we cannot do that because when you add them together, the sum will be too large. There will be overlapping. So here, if I have event A and event B, if you add them together, you are double counted this part. You are double counted this part right here, right? So there's a rule, it's called additional rule, come to the rescue. So if A and B are inclusive event, then P of A or B is equal to the probability of event A plus the probability of event B and subtract the overlapping that you double counted, P of A and B. Okay. Oh, by the way, this notation mean and. This is annotation and this is or. It's a little side note there. All right, so we have, so for event A and B, we have 4 situations here, right? They are independence events, mutually exclusive event, complementary event, and inclusive events. Okay. So let's take a look at an example just to deepen how to apply the situation for calculating probability. So a movie based on the novel was released in 2015. The probability that a randomly selected person has read the book is 15%. So I think I denote the blue circle is 15%. The probability that a randomly selected person has watched the movie is 45%. Right. So here 15%, and here it's 45%. The probability that a randomly selected person has read the book and watched the movie is 10%. Right? So this overlap here is 10%. Right? So the question is, what is the probability that a randomly selected person has not read the book? So, let me put here is book, and here is movie. And the middle will be the probability of book and movie. So what is the probability that a randomly selected person has not read the book? So this is, let's denote the P of B is the probability of read the book, and then we denote P of M. Oops. P of M is watch the movie. So the probability that a randomly selected person has not read the book is P of B complement, right? P of B complement. So remember the P of B complement, or up here, P of A complement, this right here, is equal to 1 minus P of A, right? So the probability of a person has not read the book is equal to 1 minus the probability of the selected person read the book, right? And what is the probability of a person read the book? 15%, right? 15%. So we have 85%. So answer, 0.85. Okay. Now the second question is, what is the probability that a randomly selected person has read the book or has watched the movie? So this is the or now, right? Additional rule, right? Additional rule right here. This is the or. So or right here. Okay, so P of A or B equal to P of A plus P of B minus P of A and B. So P of read the book, P of B, oops, or watch the movie is equal to P of read the book plus P of watch the movie minus the intersection with P of B and N. Well, we know P of B is 15%, right? 15%. We know that P of M, P of watch the movie is 45%. 45%. And P of both is 10%. 10%. So together is equal to what? 15 plus 45 is 60 minus 10 is 50%. 15%? 50%, right?